Because it's huge.
That is huge.
All right, you ready? So this is where we left off yesterday. We were talking about insects. We had finished up with respiration. Moving on to circulation. Okay, so for circulation, the primary organ is a heart. It's tubular shaped. It doesn't have chambers. It's just a tube. The fluid that is pumped through it is called the hemolymph. It's usually clear or yellowish. It is not red. It doesn't have any hemoglobin in it, so it's not red. It is pumped through the heart toward the head, and then it pours through the thorax, over the organs, and then goes back over into the body cavities, and eventually it returns to the heart. There's these pores that it goes through all along its length, making its way back to the heart. So that's the hemolymph. It is an open circulatory system, meaning that blood does not remain in blood vessels. It only transports nourishment and then collects waste. Remember, this does not transport oxygen because it already has a very elaborate system for respiration, so the blood does not need to carry the oxygen. But it does need to carry the nourishment to the organs, and then also it collects the waste from the organs. Yes.
When loses fluid, does it replenish?
Does it replenish it?
Yeah.
I would assume so. It still lives, but you know, it's kind of like if it loses too much, it wouldn't. But as long as it can still, I think, get the oxygen. Like its limbs, you know, if it loses a limb, it's going to be fine. Some insects even survive without their wings for a period of time. But the fluid, as long as it's washing over the organs, it should be fine, the insect. Because just as long as the organs get the nourishment they need. Because the blood does not supply the oxygen. It's the spiracles and the tubules that supply the oxygen. So I think it would be fine if it loses some of that fluid. Now if it loses all of it, not so much. But that's also why, remember we talked about how insects die on their backs, because then the fluid is not getting to the organs. Because gravity is pulling it all to, you know, the cavity that's above the heart, and so then you have some insects that die that way. And then finally we have excretion. Excretion, so once the waste is collected by the hemolymph, it's blood. It is extracted by these Malpighian tubules and extracts the nitrogen waste, nitrogenous waste, it says, and then pours it into the intestine for elimination. The water gets reabsorbed and then the waste is eliminated. Let's talk about irritability. Now what we mean here is how it responds to its environment. Okay? So they have a brain, which is ganglia, in their head region, and it's connected to a ganglion, and then there's a ventral nerve cord. Remember, ventral means it's on its belly surface. It does receive information from a variety of sensory organs. And by the way, the brain really is just a sensory relay. It does not coordinate muscular activity like it does in vertebrates. With this, it's just a sensory relay. Some insects are actually able to move each segment independently of each other. That's why sometimes an insect can lose its head and the body will still keep moving because, yeah, because the head doesn't really have a brain that coordinates everything. So each abdominal segment has its own muscle movement. Yeah, it is kind of creepy to think about. All right, so let's talk about these different senses. So smell, how does an insect smell? Yes, antennae, that is correct. Usually it's centered in the antennae. It does not have a nose. Smell is important. Do you know why smell is important to insects?
So they can find food.
Not quite. Not usually to find food. It's to find a mate. That's usually why they need to smell. Because insects release these chemicals called pheromones, and they are smells, and so they can smell them, and they're able to find a mate in different areas. Usually, there's certain chemicals released by males and females, and so that attracts each other.
Like there's some, those minks. I'm not how to say it. There's sort of skunks. Like the skunks.
Oh, okay, yeah. Like weasels and
yes.
ferrets and all that, they have they smell. All right, also I forgot to mention the antennae are actually able to measure flight speed and humidity as well, believe it or not. Taste, how does an insect taste? Well, it has a mouth, and so it does have receptors on its mouth parts. So it is able to taste the food that it eats. It's not like a huge elaborate system of taste, but they're able to taste. Touch. They actually have tactile hairs located on many parts of their body, and their limbs and their antennae. These little hairs are used for touch. And vision, sight. They have very large eyes. These are insects, right? Compound eyes that dominate their head in most cases. And so they have a really wide range of sight, right, because of these large eyes. And they're compound eyes, meaning they have many lenses. They actually think that a dragonfly's eyes are about 30,000 individual lenses, whereas with a housefly, it only has 4,000, just for comparison there. And then also some of them have simple eyes in combination with the compound eyes. And the simple eyes, even though they can't see as well with them, they do respond to light, and they can be located in on different parts of their head. So they have, like I said, a wide range of sight. And then you have hearing. How do they hear?
Vibration, vibration.
Yes, some of them actually have their organ of hearing in really unusual places. The grasshopper has a tympanum, which is works similarly to our eardrum. Because the tympanum, though, is this membrane-covered chamber. But guess where it's found? It's found in its abdomen, not in its head. It's found on the first abdominal segment. So that's kind of an unusual place for it, but that's how it hears. And then another unusual example is the katydid. The katydid is an insect that has an organ of hearing in its leg, in its foreleg. So another unusual place.
Doesn't matter which side of the leg is on. That's just
I don't know which side of the leg, so I know which leg it is. It just has it in the leg. That's kind of weird.
If they lose that, sure, I hear you.
But why do you think insects need to hear?
To make sure nobody's coming to eat them.
Nope, it's not for that.
Communication.
Sort of. It's once again for finding mates.
Why does everything have to do with that?
Well, this is why insects are so abundant.
Yeah.
Right?
They
They
gotta
outnumber
hear.
us 200 million to 1.
They gotta hear the pickup lines.
Hey Evans, do you believe in love at first sight, or should I walk by again?
Oh.
Who got him? I've heard a bunch of really bad about Wednesdays.
Oh my gosh, I read a whole bunch of them that on papers in class today. It was boring.
All right, reproduction. Ready? Separate sexes and insects. The fertilization occurs, so the male actually has to transfer his sperm to the female, but she stores it in what's called a seminal receptacle. And as she lays her eggs, then they are fertilized, because they pass over where the seminal receptacle is, and the sperm fertilizes the egg.
Is that what happens when the, you know, the love bug season, when they're connected to each other? Is that why they're connected
I
to each
wouldn't
other?
know.
I haven't seen the love bugs used to be really bad. I haven't seen them.
Oh, in our area, they get mad.
Oh, really?
Yeah.
Because I remember when I first came down here from college, there was always like really bad love bugs or PCC. And
They find little spots. It's the weirdest thing. Like I don't know what it is, but we walk in and you'll see like this cloud on the floor.
yeah, okay. But I haven't seen them in a long time. I guess I'm just not in the area where they
I
are.
haven't seen them around here in a
little
while.
bit.
And like when we used to drive in like the family reunions, my mom had like a big white SUV, and they'd always stay in her car.
Now, the female has this structure called an ovipositor, and it's the last, it's like the extension of the last abdominal segment, and that is used to deposit the eggs. It's a special structure that's only found in female insects, and she will use it to deposit her eggs, and it depends on what species of insects it is, the shape of the ovipositor, what it looks like. So the structure does vary. Oops, sorry, went too far. The structure does vary. For example, sometimes it might be more short and stout because they dig a burrow with it before they lay their eggs. You have a wasp, which is it's a long and extended stinger type thing. That's what a wasp. That's what that is. It's called the ovipositor. And there's this one type of wasp called the ichneumon wasp, whose ovipositor reaches 6 inches in length. Whew, that is a very long stinger. But the reason it's so long is because they actually deposit their eggs. It's slender and long. Yeah, 6 inches. If you think about it, you're like, ooh, wow.
And those are the things that can keep stinging you, because the bee, it stings you and then it like dies.
Yes, because it rips out their last
But
abdominal
those
skin.
can keep stinging you.
Yes.
Ugh.
But these wasps, the reason it's so long is because they lay their eggs in actually trees, but not in the tree itself. There's these beetle that live in trees, wood burrowing beetles, and so they actually lay their eggs in the beetle larvae. And so their stinger is long enough to get to where the beetle larvae are, and they lay the eggs in the larvae. And that way the eggs, when they hatch, they have something to eat. And so they end up eating beetle larvae, the little wasp larvae do.
There goes my children.
And anyway, some female insects do protect their eggs. They like put it in a mass or a protective mass and like attach it to something. They might shellac it to bark or waterproof it or somehow, because they don't really stay around and watch the eggs hatch. They lay the eggs and then they're gone. So that, you know, instinctually they do these things to help protect their eggs to keep the species going. All right, this diagram, by the way, I want you to make a note of it. This is on page 379. It's the same diagram. This will be on your test. It's a matching on your test. So you're going to be labeling just the external anatomy of the grasshopper. Okay, because the next slide has the internal anatomy, and you don't have to worry about that one. But this one is the external, so you can see where the antennae are, the simple eyes. It's really difficult to see, but they do have little tiny simple eyes, and the compound eye is much larger. The foreleg, you have the tympanum. Here's the tympanum I was talking about, the organ of hearing in the abdomen, right? And then you have spiracles are for respiration. There's the ovipositor, this is a female, so for depositing the legs. Remember, the grasshopper has the hind jumping legs. They have the forewing, which is usually leather-like. It's leather-like and it covers it, and the hind wing is protected by it. Yes?
So, can the compound eye not sense light as well? Or?
No, it can. It's just for more aid in sensing light. I don't know how well it senses light. It can see. The compound eye can see everything, but perhaps it needs the simple eyes to help with light detection. And then it is divided into a head, thorax, and abdomen. All right, it's a fairly simple diagram, but that is the external anatomy. Now, like I said, you don't have to worry about the internal anatomy, but these are all the things we've been talking about here.
It looks ugly.
What?
It looks ugly.
It looks ugly, yeah, I guess it does. But this, by the way, I just wanted to point out that, see, its heart is basically a tube. This is the heart, like in this area, and then like the blood vessel just extends from that. So it's not, it doesn't look like a normal heart. But then that is just, it comes out of the blood vessels and just washes over the organs. Notice that basically its digestive system is the largest part of itself, right? Because you got the crop, you got the gizzard, here's the stomach with the gastric ceca around it. The Malpighian tubules are for the extraction of the waste. So that's really the largest internal organ, is its digestive system. But this is a female, that's why there's ovary, and then it has the ovipositor where it can deposit eggs. Okay, now, let's talk about metamorphosis. Metamorphosis. So metamorphosis is a series of developmental changes from egg to adult, because many insects every insect undergoes some sort of metamorphosis. There's what's called incomplete and complete metamorphosis. And the various life stages that they have accomplish different functions. There are some insects, by the way, that eat only maybe during their immature stage, and then when they're mature, they die within a few hours after mating. That's called a mayfly. They live only 5 minutes after molting into an adult. It's long enough to mate, and that's about it.
Oh, that was in some movie.
The short like the fruit.
I can't remember.
Can't find a lot.
Huh? I honestly
Probably
wasn't trying
potential.
to remember.
All right, now in complete metamorphosis, there's 3 basic stages. It goes from egg to nymph to adult. Although sometimes the nymph stage may be called a naiad stage if it's in water, like with dragonflies. Now, the nymph is different. This is different than complete metamorphosis. In complete metamorphosis, the nymph actually does look like an adult insect, but it's miniature version, and it's kind of oddly proportioned, like its limbs may look too big for its body or something like that, really odd proportions to it. It doesn't have wings, because wings are for the adult. And it also doesn't have any external reproductive structures. It does have the internal, but no external reproductive structures. So what does the nymph then do? Well, it has to grow. And when an insect grows, what does it have to do? It molts. So that's what the nymph does. It grows and molts, and every time it grows and molts, it becomes more like the adult. The portions become more normal, and then eventually it will develop wings. So when it finally does develop its wings and its mature reproductive structures, it's considered an adult insect. By the way, for this stage, the diet and habitat of the nymph are identical to the adult with incomplete metamorphosis. And that's because it really is, like I said, a miniature version of the adult, so it doesn't change its diet throughout its life cycle. The only difference here would be, like I said, there are some that they lay their eggs in water, the dragonflies do. And then the naiad is very different simply because it has gills, and eventually it does climb out of the water and become an adult, start flying. Yes?
What about mosquitoes?
Oh, mosquitoes go through complete metamorphosis. Haven't gotten there yet.
I know they lay in water mostly.
All right, so complete metamorphosis has 4 stages. We have egg, larva, pupa, adult. So once the eggs are hatched, they hatch into the larval stage. Now the larva is usually it's like a segmented worm. Not always, but in many cases it is. And its most important activity at this stage is to feed. Now, so there are some common names for the larvae of different insects. Maggots are the larval stage of flies. You have grubs, those are the larval stage of beetles. Caterpillars, of course, are the larval stage of moths and butterflies. And then this one I actually had never heard before, but wigglers. Wigglers are the larval stage of mosquitoes. But I had never heard that term before. The others I had, but not that one.
I never thought of that, like, when we had a village for moths too. I was just like, oh, it's going to turn into a butterfly. So I guess it makes sense that they would turn into, like, someone turn into water.
Yes, some are moths, that is correct.
I know.
I'm
What
like a
did we
little
thought you were gonna
caterpillar.
do?
Someday
But
I'll turn
anyway,
into an ugly moth.
So what the larva does is eat, sleep, or eat and molt and grow. Eat, molt, grow, eat, molt, grow, eat, molt. That's what it does, not sleep, I'm sorry. So it's eating, molting, and growing. Eventually it reaches this form of pupa, and that's signaled usually by hormonal changes. But the pupa is a resting stage. Well, it's not necessarily a resting stage, but this is where the cocoon, if you think of the butterflies form, or not the butterflies, but the moths form the silken cocoon. Butterflies actually form a chrysalis. But this would be true of anything. Any insect that goes through this complete metamorphosis, they form this case about itself in this pupal stage. And then what happens in the pupa stage? Well, it's not a resting stage. A complete change is going on because it goes from a larva to an adult insect. It goes from a maggot to a fly. It changes from a caterpillar to a butterfly. It goes from a grub to a beetle. So there's this complete change going on within this case. Yes.
So when a caterpillar goes into the chrysalis, doesn't it liquefy itself and then reconfigure itself into a butterfly?
Yeah, it has to go through a major change. I don't know what happens actually, but.
I've heard some places that like completely liquefy its body pretty much.
Oh, really? Ooh.
Like some organs and stuff are still there.
Yeah.
But that's how it works.
And it reforms it.
Yeah, reforms its entire body. That's what I heard.
I mean, it makes sense because the caterpillar is completely different
I never-
from.
I
the butterfly. You don't really think about it much, right?
Toothpick comes in the middle of the night, exchanges a butterfly for a caterpillar.
Unless you're, what was that? What was that caterpillar on a
Bug's
butterfly?
Life?
Because all he did was grow wings.
Yeah.
Like a little baby. It's like, I'm feeding. I am flying. It's just like us. But he was still a big fat caterpillar. But
You should watch it, Bugs.
that doesn't happen.
Oh, it doesn't? I thought maybe it was like something, I don't even know.
No, it usually doesn't completely change into a butterfly. So yeah, that's why I said it's, the organs, you know, its body is dismantled and completely reshaped. I don't know if it liquefies. I don't really know the entire process of how it happens, but it happens somehow. And then eventually, the case opens up and there's a fully grown adult insect. And a lot of times it does take a moment before it can fly away because its wings have to kind of harden and unfurl and everything. But it's all controlled by hormones. I still have another thing on here too.
I just spelled metaphonesis. It's not even a thing, is it?
It is. Become elected and the little here.
That'd be weird.
Good, because I just read that. I was like,
Okay, you have homework. Remember, we're a little behind, so if you take Run Lab, this is Wednesday's assignment.
this box on. Okay, I'm a little too excited for Panera tomorrow, guys. So,
I'm
yeah.
excited too, I ordered.
I'm so ready. Oh, I forgot it comes with a cookie. I'm sorry, that sandwich sounds so good.
Which kind did you order?
Turkey bacon bravo.
Yeah.
Oh,
I like how
yeah,
you
that's what I got.
got.
Miss it.
I just had to go with the menu too.
Yeah, it's big. It's huge.
It's like an iPhone 6, but not.
No, it's bigger than that.
You got
Swipe on the back.
Maybe 6 plus.
Did you get your phone?
I did. It's huge.
Wow, what is that?
It's a Google Pixel XL. I wanted a big.
You didn't
It
catch
was
that one?
4K. I wanted a big one.
Look,
What's that?
put this
Please
up.
don't
Or not
do it.
plus
How much
wow.
was it
Sorry.
doing?
I was about, it's an iPhone
I
6.
heard you say I want to see it.
Yeah, it's pretty big.
It's way
Oh,
bigger.
I thought you said you missed that.
I mean, it's like a plus.
Evan,
Don't bring the
pause the
camera.
camera.
Oh,
Camera.
I was like,
Hey, remember
remember
Miss
that episode of Drake and
Flanagan's
Josh?
Zach.
He was like, when he was talking about the peppers, and he was like, and they say they're only found in South